Hello, it's Bob with App Jedi again for session 3 of Introduction to SQL Structured Query Language. The other two lessons have been posted to YouTube. All right, let's get started. So now we're going to talk about some other operations. We're going to be looking at subqueries, primary keys, joins, different types of joins you can do, inner, left, right, self, and outer. So subquery is a query within another query. It is also known as an inner query or nested query, and the query containing that inner query is called the outer query. Subquery can be used in a column list, from, join, and where clause. We'll look at them. So a subquery, a simple subquery in a where clause, one of the more common places to use it, it says here, select, give me all my customers where the customer ID is in the customer IDs from the order table. So this would mean all customers that have ordered something. That's basically what that means, right? This would be all customers that have ordered something. So we'll just take this query right here. Go over to my MySQL. Paste it in there and execute it. And so we'll see they have these two customers that have ordered something. Now I can just highlight this portion here in MySQL and execute just that. That's leaving off this where part and execute. You see, get all my customers. And by adding in this subquery portion in the where clause, I get only the customers that have ordered something. So that's an example of using a subquery inside of a where clause. And you can just add the not, and you get this will give you all the customers that have not ordered something. So I just add the word not over here and execute that. And this will be all the customers that have never ordered anything from us. So that might be useful. Your sales department might be wondering why haven't they ordered anything from us, or marketing, for example. They might want to send them some sort of special offer to entice them to start buying stuff. You can also add some stuff in here based on like a where clause to this, like a certain date. Maybe if you want to see customers that haven't bought something in a while, some time. So we take a look at our database. What I would do here is I would look at the order table. And we have order dates. Okay, this is old data, right? In 2022. So let's say this would go back to a date function, but let's say I could do something here. I could add this in here, and I could say where date placed is less than we take the system date, and I think if I do system date minus 365, that's a year. And we go and execute this. Date placed is less than. Oh, I'm sorry. Put that in. I still get 2. Why are you getting 2? And I think that the sys date, I'm wondering what this thing does, and gives us here. And let's add to this customer ID where date placed. So one of the things you want to do is then take this part out and say why. Oops. Why am I getting values? And I think the reason is this: I'm calculating the date incorrectly. Is why that's happening. So I'll go ahead and do that. Let's just execute that part. We get orders. Okay. So next thing I'd probably want to do is say, what is this? How is this exactly calculated? And I think we have to use an actual date method or something like that. There's a date function for taking. What are we getting? So this is giving us 224 is less than. Yeah, so that's 365 is actually giving you in milliseconds, I think. So you'd have to do something like 365 times what would it be? 24 times 1000, I think. 24 days, and actually times 12 as well. You have to do something like that. Because it's actually the date's keeping the date in milliseconds. Let's see if that is correct. And no, it's still giving us something here. 24 is giving us something. Oh, 30. We had 30 in there as well. 30 months, 24 hours, 30 months. Oh, times 60, because 60. Okay, actually have to do all that. This should give us like a year. Dates in computer systems operate on what's known as milliseconds. And that's kind of why you have to do that. This actually should be an easy way to do this. Now, this gave us something wildly different, giving us a numeric value, and it still gave us those ones here. All right. So there's an easier way of doing this. There's actually a date function we have to look at. We're going to get to date function somewhere in here. And what I'm going to say is that where date placed is not like 2024%. So I'm saying not like, what that means is that they didn't order anything this year. Then, and why did I get that? Should not have gotten that either. Oh, I should say is like, I'm sorry. Because here it's saying in, okay, this should say like. So not like. There we go. All right. So if you look at this here, so something they ordered. Now we know that if we look at the orders, we do have orders in 22. So I could just change this to like 22. And I do get those two orders. Now, what I could have put, I could put this back to 24. We're getting that in. So that tells us that we haven't sold anything this year to any of our customers, is basically what that tells us. So you can put in these where clauses and these subqueries, and you can put a where clause, is what I'm trying to say. And then also there is a way of doing it with the dates. We haven't gotten to date functions yet. I am going to cover date functions in one of the future videos, so I won't go there today. But I think it's actually the date diff function you'd have to use. But there's more than one way to skin a cat. So you could also just do something like this, which gives you that result as well. So there's also the exist clause. So, which is an alternate. The exist clause is more useful when you're looking to see if a single record exists. There's a good example when you look at coming up when validating whether, say, a user exists in your users table or if an email is taken. But I'll show this example here, and oops, what happened? So we're saying this exists where the regular price is greater than 100. Right? And there is none. If you change that to greater than 10, you probably would get some. Right? You get a whole bunch of products. And the second version is not exists. That's probably going to give us more or less the same list of products. Right, a bunch of products. So we're saying, I guess we don't have any products. So here we could take this guy right there and just say, do we have any products? Change that to an asterisk. Do we have any products? No, we don't. Okay. So that's correct. All right. Compounding queries. So basically in the where clause, you can compound them in a parentheses when you're using a subquery. So in this example here, we have our two tables, customer and customer new. That's the example where maybe one company purchases another company, but the two companies likely have customers in common. So you want to say, well, we want to merge the two customer tables. We don't want to have duplicate customers. So there's a number of ways of doing it. You can do some basic SQL that will help to reduce it a lot. But in my experience, you're gonna have to go beyond that. You're probably gonna have to go and use a scripting language like Python as well to help you in the merging process. So there'd be like a couple of passes or really something like Python working in combination with SQL. I did a lot of this when I worked in healthcare. Company I worked for owned several over 30 hospitals, and they would buy a hospital from time to time, and then we would have to merge the patient records. We couldn't have duplicate patient master records. That would be a real problem. So we had to merge them, and I did a lot of this back in the day. And yes, I use SQL for usually the first pass, but then almost always you needed to also do something else, some sort of scripting language. I've done it in Python. I've also done it in Perl, and a number of good options for that. But this is one option here. So now we're finding all the customers with in our primary customer table that share the same first and last name as customers in the company we just bought, right? And that might be a first pass. There's other things you have to look at because you've got very common names. So this isn't going to work. You have to look at other things. You probably wouldn't have a social security number. The nice, well, you might, but it's kind of restricted what you can do with a social security number. The nice thing, I guess, working in healthcare was healthcare companies were allowed to ask for social security number. And a lot of banks and stuff can ask for it too, but there's some laws regarding privacy on social security numbers. So doing that might be problematic. Also, you may not have a social security number. There was a time when you didn't get a social security number until you started working. And back in, old traditional days, women may not have worked. So what they did was they would just use their husband's social security number. And that was problematic if both the husband and wife were patients in the hospital. That doesn't happen anymore. You get a social security number as soon as you're born. Of course, in other countries, it's different altogether, right? And if you got an international company, well, that's out the window there, right there. So it can get very problematic in trying to merge data sets. It's possible, but it's problematic. It's a challenge, and it's generally using more than just SQL. Correlated subquery. The correlated subquery is where the inner query makes a reference to the outer query. That's correlated. Normally, with a subquery, the inner query executes completely, and the results are then fed to the outer query. That's not the case with a correlated subquery. In the case of a correlated subquery, they are executed in parallel, which means one row is executed from the inner query. That result is then fed to the outer query, which queries a single row. And the reason is because a value from the inner query is needed at the individual row level of the outer query, or has to make a reference to the outer query. In this example, we have the product table P, and then giving an alias of P. The inner query, which is just taking a count of rows from the order line table, but in the where clause, it is referencing the table in the outer query, the ID. We're trying to get a count. Basically here, we're trying to get a count of all products for a particular product. All orders, I'm sorry. All orders for a particular product is what we're doing. Now, there are other ways of doing this, simpler ways of doing it. This is just an example. We're going to get to aggregates next session, and also something called the group by and having clauses. That's actually an easier way of doing it, but this is a good example of a correlated subquery. I'll go ahead and execute this one. Okay, and you get those results there. Subquery and a join. So the subqueries can be used almost everywhere. We call the last example, the subquery was used as a column, right? This is generating a column. Next example, the subquery is being used in the join. So now what I'm doing is the from, and then here, and this is actually subquerying the from, not the join. I'm sorry, that's a bit of a mistake there. That's in the from part. We'll get to using it in the join later. Here, in the from, where this is basically, what you're basically doing is you're creating a temporary table. when you're doing it this way, you're creating a temporary table for the purpose, and this temporary table only exists for the duration of the execution of the query, and you have to give it an alias. An alias is required. So this OC alias as alias name OC is required. You can give it whatever name you want, but it is required. And then the where clause, we are referencing the product ID in the subquery based on the alias. Alias right here references that product ID, which is in the subquery. And then we're comparing it to the product ID that's in the outer query. So this is not actually a correlated subquery, however. This entire thing is executed immediately before the outer query is executed. And then a temporary table of sorts is created with the alias OC. And then we are comparing them in the where clause to get this output. Now, later on, we're going to talk about things like views and also something called a CTE as another way of doing it, and arguably a better way of doing it. Okay. But there's many different options in SQL. There's, like I said, there's more than one way to skin a cat. Okay, so now I'm going to look at joins. Joins, there's a couple of different types of joins. The most common is the inner join, which joins records from two or more tables that have matching values. And those values are generally matched by what's known as a key between them, a key and column between them. A primary key in one table and a foreign key in another table. We'll get to that. The other type, which is also fairly common, is called a left-outer join. The reason inner and outer are in parentheses is because they're optional. You do not have to say that. Join or inner join is the same thing. Left-outer join is the same thing. Left join and left-outer join are the same thing. Right outer join. So first, left-outer join returns all rows from the left table and the matched records from the right table. So whether there's a match on the right or not, you still get all the rows from the left. Right join does just the opposite. Returns all rows from the right side of the table and whatever matched rows there are from the left. You've also got a full outer join, which returns all records when there is a match in either the left or right. A note on this is that MySQL actually doesn't support full outer joins. I don't know why, but it's easy enough to emulate a full outer join in MySQL by using a union between a left and right join. I'll show you an example on that. A self join is when you join to yourself, right? You join to yourself, a table that joins to itself. And there are purposes for that, and we'll see an example of that. Okay. Here, before we get to the actual join here, this is showing an example of subquery in the join. I got these flipped. Let's just say join. Subquery in the join. Where now you've got the from clause, we've got this temporary table again, but instead of in the where clause comparing the product IDs, we're doing a join. It's very similar, but we're using a join instead. But this is just to show an example of how you can use a subquery with a join. Okay, so talk about primary keys and foreign keys, very important. And this also gets to normalization. And we're going to talk about normalization later. So primary key, the column or columns that uniquely identify a row in a table. Best practice is a single column integer auto-generated key from the database. Foreign key is a primary key of another table that links 0 to many rows in a foreign key. And let me show you an example of this. Ooh, what happened? Okay, good. Back to that. Okay, so example, we have customer. Customer ID, that's the primary key. If I do a right click on this and I go to alter table, what you're going to see here says ID PK, primary key, not null, auto increment. AI, this AI here means, okay, let me go over this. PK means primary key. NN means not null. It means it cannot be null. It has to have a value. Primary keys cannot be null. They have to have a value. AI up here stands for auto increment. That means it's going to automatically create an ID for something. And that's very important because basically a primary key should not be a real world value. Some people might say, well, why not social security number? It's unique. Well, I just told you why social security number is not a good idea. They may not have it. Are you only selling to Americans? Or are you selling it globally? So also it's a real world value. What's the problem with real world values? Typos. Someone has to enter that social security number in the computer system. What if they type it wrong? Oops. And now what happens is since these keys are used to relate items to each other, if you have a typo and now you got to fix it, then you've got to fix that key where it's incorrect everywhere in your database. That's what's known as an update anomaly. An update anomaly is when an update to one table requires an update to one or more other tables. That should never happen. That's because you have denormalized data or you chose a real world value for a primary key. So looking at customers, what do we know with customers? We have no customers. Where are we at here? Customers have orders, right? Got a customer number, right? Customer number right here. It's customer ID. That's the customer ID there. In the get over the customer table, right there. So here in order, we've got customer ID 1. That means that Jane Test made that order. Now, in order, customer ID is the foreign key. It's a foreign key because customer ID is the primary key in the customer table. And the reason you need that in the order table is because we need to know what customer placed that order. That's why, right? So if I want to get the customer and we did something like this, over here, we did something like here. Let's go here. And let's say we want to say select C dot last name, C dot first name. And I'm going to do also the customer ID. Say C dot ID. And let's look at our order table. Let's just take the date shipped. Order.date shipped from customer C join order O. And this is the reason that's blue like that is because order is a reserved word in MySQL. I should have called this orders instead of order, but anyway. That would have been a better name. On C dot ID, which the customer ID is equal to O dot customer ID. So this is doing a join here. And if we execute this, we will see, what's the date ship? Why didn't that work? Oh, I want date place, not date ship. Okay, let's go to date place. Okay, date place. Of course, they're all placed on the same date. But what I can also do is I can add the order number to this. Let's add the order number. I think it's O.ID as order ID. Okay, so order Jane Test order ID 1. If you go look at over here, you'll see order ID 1 is customer 1, order 2 was customer 2. So go back to the query, and we have customer Smith, order 2. Jane Smith again was order ID 3. Is that the case? Yes. Right. So that's the case. So that primary keys and foreign keys are necessary to do these joins. And they're necessary to associate table data with each other. You would not know what customer placed this order if you did not put the customer ID as a foreign key in the order table. That's the way it works. Primary keys, getting back to that, the best practice is a single column integer auto-generator. Okay, so why that? Single column. It's more efficient. It's less error prone. It's less prone to things like update anomalies. And why would you need multiple columns? You shouldn't need it. It's got to be a unique value, just like your social security number in theory, or whatever your national ID is unique. It's supposed to be unique. You can't have two customers with the same ID number. Then which one of them may place the order if they have the same ID number? That has to be unique. Integer is the most efficient data type. That's why integer. Auto-generated. That's to guarantee there aren't any typos, errors. Human beings make mistakes, computers don't. So if you tell the computer, I want you to auto-generate a number, and it's going to, when you first create the table, it's going to start with 1, and it's just going to increment up 1, 2, 3, 4, and so forth. Computer does that automatically. It's guaranteed. It's not going to make a typo. That's why it's got to be auto-generated. Now, the foreign key is simply a primary key of another table that links that table back either 0 to many rows in that table. So what does that mean, 0 to many? That means that a customer, which is the primary key, can have 0 to many orders. You could have a customer with no orders. You could have a customer with 1,000 orders. Doesn't matter. But the foreign key links the primary table, in this case customer, to the secondary table, in this case order, based on that primary key, foreign key relationship. Right? The customer ID is the primary key of customer. It is a foreign key in order. And that's how you know what customer placed that order. It's how you know all the orders for a given customer. Oh, we just look at this. This is the query we just did right here. It's the query we just did, right? As an example, right? Where is it? No, here we go. That's the one we just did. So we just did that. You can go further. You can say, oh, they placed an order. Well, what did they buy? That's in the order line. So if we look at the order line table, now you can do a join can be more than one table. So here we can do the join to the order. You can find out the product ID and the quantity. Okay. So I can do a join. I can also do a join to order line, say OL on O dot ID is equal to OL dot probably order ID. I'm guessing it's the order ID. And I want to add into that, what can we get from the order line? We can get the quantity and the product ID. Okay, that doesn't tell us very much. But let's just put in quantity first. Let's put quantity and product ID. Let's do OL dot product ID OL dot quantity. Okay, see what we get. Okay, so they bought 2 of product 2. What the heck is product 2? Okay, so we have to go a little further. Product ID. Well, what is the product? Let's look at product. Name. We got the name. We got the current price. Okay. So now we want the product name. We also know, gee, product ID. I'd like to know what the product name is. So now let's say P dot product name. Okay. Now, but this now, in order to get that, we also have to join to the product table. OL dot product ID is equal to P dot ID. Okay, let's try that one. Yeah, we got there somewhere. Product. We'll come up for a second. Product. Oh, it's just called name. Okay. All right. Okay. So we're going to say P dot name as, we'll call it product name because we actually want it to look like that a little bit better. And there you go. So now we know what they buy. Product ID, coffee, quantity 2. You might say, well, what did they pay for it? Well, this is not really good because prices could change. The price they paid for it probably should be added to the order line table. Is it in the order line table? No, it's not. Oh, well. It probably should be in properly done. Actually, this price would be in the order line table. Why? Because prices change. You might give them a discount. We can add the current price to the query, but if this was being done for real, you would actually put the price in the order line table. Current price. Current price, okay. Okay, yeah, that. Okay. So anyway, that's another example. Kind of shooting from the hip here. But I'm going to add this to my PowerPoint. All right. So here, I'll call it multiple joins. And just put that in there. And reduce that aside a little bit. All right. So that's a more complicated one. And okay, so that one's another one we're going to try right there. Let's see. Left join. So we're doing a left join the customer. What this is going to do, we just change this a little bit. We're going to go back to the simpler query version of the query. Going to go down to the simpler version of the query. Now what this is going to do is it's going to give us a list of all of our customers that have never ordered anything. Or no, I'm sorry. Going to give a list of all of our customers, including those that have never ordered anything. And you'll see over here at the bottom under date place says null because it didn't find a match. Okay, so that means it didn't find a match. So they didn't play. We probably should add the customer ID to this thing here. What a good idea. So we can say, so now we say that customer ID 3, 5, and 7 have not ordered anything. If we go into our order table, we'll see under customer ID, we don't see any of those IDs in there. So they never ordered. So the customer that's never ordered anything might be a new customer. It might be someone that, you know, your marketing department wants to reach out to. Why haven't they ordered anything from us? So you might want to reach out to them. So this might be a report that you know, marketing department might want. Someone, a customer who's never ordered something, or maybe they haven't ordered something in a while, you know, feeding off of the date placed. They might ask you, can you give me a report of all our customers that haven't ordered anything in the last year? And you would run a query similar to this to get that. And that's pretty common. So SQL a lot of times is used for data analysis. It can be used, it's used in full stack applications on the back end, and I'll show you an example of that, where it's used. It's used in the back end, but it's also used for data analysis. And a lot of times the data from sales will be copied into a separate database called a data warehouse. So that like the sales and marketing department, business development, whatever they call themselves, can do some analysis on the data. And it's really about, you know, they're doing the analysis to figure out how they can sell more stuff, basically, is what they're doing. But you'll use queries like this and you use more complicated queries. So there's databases or SQL for full stack applications, and I'll talk about that. There's also SQL for analytics. Basically means analyzing data. SQL is also a core technology in artificial intelligence and the data and AI, because artificial intelligence is basically just a more advanced data warehouse. That's all it is. But I'll get into that later. Okay, a right join is the opposite of a left join. You're just saying, just flipping it around. You're saying, give me all the rows from the right side plus any matching rows from the left side. So, you know, there's not much of a difference here. If we execute this one, right, you get the same result there. And that's because you're saying, give me everything from the right table, the order table, plus whatever matches you have on the left. Well, the reason is okay, the reason you got the same thing is it's not possible for a customer or for an order not to have a customer. An order has to be associated with a customer. So that's why you didn't get any null values. If we switch this back to the left, you would get it, right? Because it's possible for a customer possible for a customer not to have an order. That's possible. It's not possible for the order not to have a customer. If that's the case, you have something called a data integrity issue, which means a parentless child. In the case of these relationships, parent to child, which is primary key to foreign key, a parent, in this case, customer is the parent, does not have to have any children. However, a child cannot be an orphan. Not allowed to have orphans in normalization with relational databases. So what does that mean? Order is the child. It has to have a parent. So in this case, we're doing parent to child left join. In the other case, we're doing child to parent to right join. We're doing a parent to child, or child to parent. The child has to have a parent, so you're not going to see any nulls in the customer table. If you see that, like, oops, you've got a data integrity problem that you need to fix. Another example of a right join. Looks like this is right join. This is the same one. It's the same one. Oh, okay. In this case, we're flipping it around. This is going to give us the same result as doing customer left join to order. We're just kind of flipping it around. We're saying order, right join to customer. We're putting the parent on the right side. You actually would probably never do this. This would be like, you're supposed to join parent to child, not the other way around. So I'm showing you something here for the sake of showing it that you should probably never do. But it gives you the same result as doing from customer left join order. It gives you the same exact result. Okay, it gives you the same result as saying I could change this to left and I have to move everything around. But if we made this left and then we flipped customer in order, customer on from and order down by after the join, you get the same exact result. Here's an inner join. I think we've already looked at this. We already looked at this inner join. Oh, in this case, the other difference I'm adding here is I'm saying you can have a where clause, right? I'm just saying you can have a where clause. See, you can add a where clause anywhere. The fact that you have you're joining two tables doesn't mean you can't have a where clause. You can filter it. So in this case, we're joining customer to order, but we only care about the orders for customer ID 1. That's all we're really saying there. Joining itself, a table, this is a self-join. This is joining a table to itself. An example here might be an employee. An employee has a manager, but the manager is also an employee. So let's take a look at this employees table. Here we got some employees: Mickey Mouse, Donald Duck, Fred Flintstone, Barney Rubble, Betty Rubble, George Jetson, and James Kirk. Mickey Mouse is the CEO. He does not have a manager. He's the CEO. You could say, well, he reports to the board of directors, but anyway, just for the purposes of this lesson, he doesn't have a manager. You could have made this a null. I made it a 0. The department ID the manager's in. Now, Donald Duck, the manager, his manager is ID 1. That manager ID is the employee ID of his manager. So who's his manager? Mickey Mouse. Fred Flintstone. Also manager ID 1, so Mickey Mouse is also his manager. Now you got Betty Rubble. Manager ID is 3. So Barney Rubble reports to Fred Flintstone. So does Betty Rubble. Then have George Jetson. Different department, 3. Manager ID 1, reports to Mickey Mouse. James Kirk also reports to Mickey Mouse, right? So if we wanted to get a report of all of our employees and who they report to, we would do a query like this. We're selecting E.last name, comma E.first name, comma M.first name as manager last name. I'm giving it an alias there. M.first name as manager first name. From employees E. Okay, joining from the employees table, and I'm giving it an alias of E. I'm joining to employees table, the same table. I'm giving a different alias. That's required. If you're joining a table to itself, you have to give the tables an alias. because there's no other way of referencing, of saying which one of those versions of those same table I'm referencing. So you have to give it an alias at that point. On e.manager, the manager in the employee version of the employees table is equal to the employee ID of the manager version. And we do all that. And this is the result we're going to get. We'll put it in here. I'll go show you. Here. Execute that. So now we get it. Like I said, so Fred Flintstone, managers Mickey Mouse. Barney Rubble, managers Fred Flintstone. Same thing, right? Fred Flintstone. And both George Jetson and James Kirk, their managers Mickey Mouse. So if you want to get that, who are all my managers and who are their employees? And you might want to do this a little differently. You might want to get a report of who are the managers, my managers, and who reports to them. So you just kind of flip this around a little bit, is all. Now, the other thing you might want to do is do an order by. You might want to see managers and who are the employees. You might want to do an order by. In this case, you probably might want to have it be alphabetical. So it would be M dot last name, M dot first name. And there you go. So manager, well, this is alphabetical order. So Fred Flintstone is the manager. He's got 2 reports. Betty and Fred Rubble. Mickey Mouse has 4 reports. So that might be, you know, another report. This might be a report that Human Resources requests. Give me a list of all my managers and who reports to them. Mr. Data Analyst or Mrs. Data Analyst. So you might do something like this. Full outer join. A full outer join is a type of SQL join that combines the results of a left join and a right join. It returns all records from both tables, matching rows where there's a match between the 2 tables, keys, including nulls where no match is found. So, you know, key points, matches where match exists between the 2 tables, rows are combined. Non-matching rows, no match in either table, including the results on different rows. The results include all rows from the left table and all rows from the right table. Combined, where they match, they're combined on the same row. Now, this is what a full join would look like. This full join will not work in MySQL. I don't know why. It works in Postgres. It works in SQL Server, Oracle. You know, what I will say is full joins are probably not something you do very often. And it's very easy. It's also very easy to emulate a full join in MySQL by using a union of a left and a right. So I'll show you what would work in MySQL is right here. It's doing a union. I'm saying, whoops, hold on for a second. Here. Doing this query, doing a left join, departments to department ID, and employees and their department, and then doing a union, the same, but doing a right join. So a union of a left and a right join is the same thing as a full outer join. So that's how you emulate it in MySQL. And I don't know why they just didn't leave it out. But so now you'll see here is that, for example, James Kirk does not have a department. If we look at the employees table, you'll see James Kirk, there's no department ID, it says null. And that's what we see in our output, no department, not assigned to a department. Now, what it's also showing is that human resource doesn't have any employees, which is, you would never see that, but this is just play data. If we look at, so if you look, it doesn't have a manager, I should say. This is a report of departments and their managers, right? And again, that might be another report you want to see. Departments and their managers. And a drill down of that report would be department, manager, employees. So the department, the manager for that department, and all the employees in that department. That's somewhere where you would join multiple tables together. So in this particular case here, we have kind of doing, this is kind of a, where are we at here? Giving me, There we go. Good, it's better. So here, what else do we have to do here? This is employees. So this is going to employees to find out who's the manager. But what if we want the actual employees as well? So here, let's put this down and make this manager. Because this is actually the manager of the department. Let's say as manager last name, give us an alias. Okay. And we probably want to put department first, actually. In this type of, say, report here, you probably want to put department first. First name as manager first name. Okay, now we want to get the employees as well, right? So now we can say, and we have to prefix, all this has to be prefixed now. So M dot, because we're going to have the employees. So this would be like a more detailed report you might see. We have E dot last name. Well, we probably should give this a label as well. Employee last name. E dot first name as employee first name. Okay, that's it for that, but we have to join some more tables. This is doing left joins. I guess we'll just stick with that. Left join employees. E on. In this particular case, the employee has both a manager and a department ID. So you could actually join to the employee table using either. So let's just use department ID, I guess. E dot department ID is equal to D dot department ID. Okay, so doing all that. Now this will not work. Get an error. Basically, the error is saying that in order for the union, we're going to get into unions a little bit more later. The columns have to match. So we have to take all of this here. We really probably just need to take this entire query and duplicate it. Except we have to change the right joins, the left joins to right. We just have to change these to say right. Okay. And there we go. Now we got it. All right, so we have the department name. Stuff down here. All right, so you got the department name. The operations, right? Mickey Mouse. Yeah, you got Donald Duck. Donald Duck. They combine. You got Kirk. This is yeah. Do we have any duplicates here? Oh, sure. Oh, I see. Well, Fred Flintstone doesn't report to itself. I think that we probably should have done the join on the manager ID instead. E dot manager. I think that probably would have been better. Yeah, it looks better. I think it's showing Donald Duck. It's showing him a report. He's a man. Oh, that's okay. Actually, that's correct. That is correct because yeah, he's the manager of the department. He's also an employee in the department, so that's fine. That's correct. That's right. Okay, so that's a more complicated one, advanced way of doing it, and I'll create a. I'll just add this to the PowerPoint if you guys don't want to try it. Okay. We'll call this the HR department report. Okay, so it could be there are jobs in companies where you're just a data analyst. And what is the data analyst is doing? The data analyst in a lot of cases is running a lot of SQL queries. Now, you might be taking the SQL queries and either downloading the data to something like Excel or some other reporting tool. Excel is pretty popular for data analysts. It could also be a more advanced reporting. You might also be using something like Python. That's pretty common as well. Later in the course, I am going to show how you can connect Python and Java and JavaScript to a MySQL database. That'll be towards the end of the 12 course series. But that's it for now. These will next week there'll be another one, and leave a comment, subscribe if you can. If you have any comments, suggestions how we can make it better, don't worry, I have a thick skin. And yeah, anything else you might want to see in this course. Thank you.